Hello everyone, it's Benny, and welcome back to the 3D game programming tutorial series. Last time, we managed to pretty much get entities in a solid place. We can create entities, and we can remove entities. It works beautifully with the whole ECS system. But that doesn't mean very much. We don't have components. We don't have systems. So we can create entities and they do absolutely bupkis. So today, we're going to remedy that. We're going to start working on the component methods so that all this just works. That is the topic of this video. Let's get to it. So we have three methods to implement: add component, remove component, and get component. Now, last time we ran into some trouble because we needed to remove component and we didn't have it. We had to create this sort of stub method just to prevent compiler errors. So, of course, of the three methods, it makes the most sense to start with add component. Because plot twist viewers, we've already implemented this. Yeah, you might not have recognized it, but right here, where we're adding the component to the entity, that's add component. That's exactly what we need to do. So, all we're going to do is we're going to create another method like this. I'm going to call it add component internal. It'll be the non-templated version that all the templated methods call. And what do we need for this? Well, we need the array of pairs because that's what our entity is. So take that as a reference. I'll call that the entity. We need the component ID. So I'll UN32, call it component ID. And last but not least, we need the base component index. No, index, you know, the base component pointer. And that's going to just be called component. There we go. At this point, we can go ahead and implement this. So this is the internal version, the one where we don't need to know about the type beforehand. We just need to know, we don't need to know about the type at compile time, I should say. So we're going to be doing exactly this. I'm literally just going to copy and paste and replace the name. So new entity second can be replaced by just entity. And new pair, that's good. Component IDs can be replaced with just component ID. And entity components can be replaced with just component. Yeah, we just pass in straight up component. And I almost forget this IDs. That one was sneaky, but that appears to be everything. So at this point, we can replace what we did here with add component internal. We'll pass in exactly what we just replaced, the new entity second. We'll pass in the component ID, which is component IDs sub I. And we will pass in the component itself, which is the address of this. And there we go. Now we're done. And look how much simpler that makes this method. It really cleans it up a bit, makes it a whole lot simpler. Now we can really just go ahead and implement this. In fact, I might even be able to do it inline. Let's see how that works out. So for the tentatively inline version, what we need is we need to get we're basically going to be calling this at the end of the day. We need the entity, so we'll need handle to entity. Here, I'll just go ahead and make this full screen so it's easier to work with. Handle to entity. We need the component ID, which we can get from component ID. Note I'm using component as the class itself. And we also need just components. So yeah, we can just do this. It's just a straightforward pass-through to calling add component internal. Let's see, can we do something similar with the remove component internal? I don't know that we can, because actually this requires additional logic to remove it from the entity. Remove component internal here doesn't remove it from an entity. Okay. So that'll be a little bit trickier. And we'll go ahead and do that next. So, to start with, to make things a little less confusing, I'm going to rename remove component internal to just delete component. Because really, that's what it's doing. It is straight up removing a component from our map of existing components, and it doesn't care what entity it is or isn't attached to, it's gone. That is what delete component does. Now, logically speaking, we're going to be doing something very similar to what we did in remove entity. It's going to be a little bit complicated by the dynamic type system, and another thing that we'll come across in just a second. But the general concept is the same. We're going to want to get the free function from base ECS component. So the free function is going to be base ECS component, and I'll just say get type free function, wherever it is. There you go. It's trying to save some typing. That's fine. Component ID. There we go. Oh, right. I forgot to give it a name. I'll use my usual convention of calling it free FN. And yeah, the other thing we're going to need to know is we're going to need to know the size. So size T, I'll call it type size, sure. And yeah, once again, base ECS component, get type size. And it's going to take in component ID. So that's what we need to do this. And this is where things get a little tricky. So to pull off the swap trick, just like before, we need the source index. Unlike before, it is not just going to be the size of the array, which by the way, we don't have yet. So actually, let's do that first. So I'm going to have an array of uint8. I'm going to take it by reference. I'm just going to straight up call it array because that's all this is. It's just a blob of data. I don't think you can give it too much more of a meaningful name than that. And so that's the array, and it's going to be equal to our components sub component ID. So this is the array for this particular type of component. Now our source index, like before, it's going to be the element at the end. So in this case, array.size minus type size. Yeah, you have to be careful about this because this is just blobs of data, not the type we're interested in. So the source index. Now, what we need is we also want to be able to access the component. So I'm going to say base ECS component pointer. I'll say, sure, source component. That's going to be equal to the array sub the source index. And we're going to take the address of that, so referring to it by pointer, and we're going to cast it to a base ECS component pointer. Again, that's safe because whatever type this is, it's definitely some form of ECS component. So this is a safe cast. And we also need a dest component, which is just going to be straight from index. Now, here's where things get tricky. No matter what, we need to call the free function on the dest component. And wait, am I calling it right? Yeah, I thought so. It just takes in the base component pointer, yeah. So this is correct. We are calling the free function just like before. Unlike before, we're going to want a special case. Basically, if index is equal to source index, then at this point, what I'm going to do is I'm going to use array.resize to the size of source index, however big it needs to be able to handle that, and just return. So this is a special case where we are removing the final element of the array. And that's important to special case because unlike the entities array, order does matter in these components. And it makes sense if you look at our entities. How do we refer to our components? Well, we have the ID and its index in the components array. If we start shuffling everything around, that's a problem. So we're actually going to have to take care to update the entities that refer to the component that we're moving so they're pointing to the new index. I know it's a little tricky, but it's important we do that or the whole thing breaks. So to start, we can do the easy part. Assuming all the indices are updated correctly, what we can do is just do a straight memory mem copy to the destination component from the source component, and we know the type size because of our amazing dynamic runtime type system. So we can do this, and it works out just fine. So this will overwrite the destination component with the source component, and as long as we update the references properly, that should work. And as before, at the end, we will need to resize to a source index, because that will be the new end of the array. We're getting rid of that final element. But in between these two operations, we need to update the references properly. So how do we do this? Well, if you remember from oh so long ago, by which you mean like 2 or 3 videos ago, in ECS component.h, we had this thing called the entity that refers to what entity a component is attached to. So what we can do is say source component arrow entity, and just like that, we have a handle to the entity it's attached to. At that point, it's really straightforward. We can just say handle to entity for this, and this returns an array of this, and I'll just call this source components. Sure. Maybe slightly confusing terminology because there's only an S, but well, it's not that confusing, so I'll go with it. And yeah, so at this point we just want to iterate through every single component because we don't know where specifically it is. Source components dot size, and whoops. There we go. And now what do we do? Well, how do we identify that we know that the source component is attached to this entity somewhere. How do we know we found this component? Well, first of all, it has to have the same type. So if component ID happens to be equal to, and if you look in our entity type thing, yeah, we have a pair that tells us what type it is. The pair is the first one. So source components sub I arrow first. That is the type. So if this is the same type, technically that should be enough because I'm not planning to allow us to have multiple components of the same type on the same entity. But just in case we somehow want to do that, we can add a second check, which is on the second one. If source and source index is equal to source components sub I arrow second, because this should be telling us, hey, this is where the component is in the array, and source index, go figure, is that location. So this is definitive. This is definitely the same component if these conditions are met, no matter what design decisions we ultimately end up making. In this particular case, what we want to do is update. So what we're going to do is we're going to basically just change. Source components dot first actually can stay the same, so I don't need to update that. It's still the same type, but the second is going to become just index. And technically we should be able to return at this point, or break out of the loop. And yeah, I'm going to go ahead and do that. If I really need to have multiple components, multiple references to the exact same component on entity later, I can deal with the repercussions. So that will update the component properly, then we can resize, and we should return. All is good. We finally have our delete component method up and ready to go. And as always, we have a few minor oversights. First of all, in remove entity, we did not change our remove component internal to our new name delete component. That's kind of important. Also, delete component and add component internal do not have the ECS prefix, so that's kind of important. And lastly, I for some reason have some obsession with referring to pairs by pointer because these are not pointers, these are just straight up pairs. So replace the arrow notation with dot in our loop. And there's just one more issue, and that is add component internal is missing a parameter. We also do need to know about the entity handle. And yeah, that's because, well, right here we are using it. and we can't go from entity back to handle. So we're going to do that. And it's just going to be the first parameter. We will pass in the handle. And I think under add component, yeah, I just need to pass in entity. And that should be everything. But it is not everything, because I forgot to include core/memory.hpp. And that actually is everything. So with that, now we can move on to implementing remove component good and proper. So first off, I'm going to create a void remove component internal. And this is going to take in a entity handle and a component ID. So here's how we're going to implement this. If I scroll down right below delete component, I'm going to have ECS remove component internal. Whoops. And what we're going to do is something pretty much like what we did up here. In fact, even going to just copy and paste what I did in delete component for a moment. So we're going to go through the entire list of components. I'm just going to call these entity components. Thank you. Handle to entity just takes the straight up handle because we have it. We're going to go through entity components.size, and if the component ID is equal to component size.first, then we have our component to remove. So what we're going to do is we're going to delete the component at this index. Note this does not actually remove it, because that's just how we wrote the code. So entity components sub-I dot first, yes, and I'm not doing the arrows this time, and second. Awesome. Now we've deleted the component, but that's not enough to remove it. We also need to get rid of it from the array. So what I'm going to do is pretty much the same trick we've done all along. I'm going to end up swapping this with the final element in the array, and then we're going to end up returning. So here's how I'm going to do this. Like before, I'm going to have a source index, and that is going to equal entity components.size -1. And I'm also going to have a dest index, which equals I. You might see where this is going because it's pretty much what we do in remove entity. So, in fact, I don't need to copy. I was thinking about it. I thought about it, but no. Entity components dest index becomes the source index because we've deleted the dest index. And last, but most certainly not least, we need to pop, which we should be able to do while we're iterating. We're not doing, this isn't like the ridiculousness of Java, so this should be okay. Dot pop back. Perfect. And with that, we can return. And this should remove the component, because we're going through all the components. If the ID is indeed the one we're looking for, then we delete that component. We replace it with the component at the end of the array, and then we remove the component at the end of the array. Again, this works because we don't care what order the components are listed in our entity. And now, at long last, we can implement remove component. So, remove component, we're going to, guess what? Call remove component internal. I know, what a concept. We're going to pass in the entity and component :ID. There we go. That's it. We're done. And as always, we have a small typo. Source index should not be by itself, but entity components subsource index. So that's that. And now we just have get component left, and our components will then be done. So as with add and remove, we're going to add a get component internal method. And we're doing this for more than just aesthetic reasons, by the way, but I'll talk about that in a second. Our parameters are going to be the array for the entity components, sure, and the Uint32 component ID. I'm sure you can guess how we're going to implement getComponent, so I'm just going to go ahead and do it. We're going to call getComponentInternal. We're going to use the handleToEntity method on the entity, and that should get us the list of components. And for the ID, we're going to use component ID. There you go. That's it. And now we just need to implement getComponentInternal, and we're done. But as I was saying a few seconds ago, the reason we want to have these internal versions of the method rather than doing it directly in the templated version is twofold. One, anything we put in the templated version is going to get duplicated for every single different type. This will minimize the code duplication. The other reason is because we're actually going to be using these internal methods internally. Go figure. So, yeah, we're going to be taking advantage of that. You already saw a little bit of that with addComponentInternal. And yeah, we're just going to be using them in a few odd places here and there to implement our ECS system good and proper. So, with that, oh, and the reason we need the internal version is because internally inside the ECS system, we don't know the type name at compile time. We only know the type at runtime. So this gives us a way to do that at runtime with only the runtime type information. But anyways, now for getComponent, very simple. We're going to go through the list of components. If, you never guess this, if that component is the component we're looking for, guess what? We have found the component, viewers. Sort of. Not quite though, because actually we do need to go and retrieve it from the list of components. So under entity component subi.second, what we're going to do is we're going to go for components, sub component ID, and the index is entity components subi.second. That, yeah, because by definition, this is the index in the components array. So with that, what we can do is we can take the address of this, cast it to a base ECS component pointer, and just return that. Which, by the way, why on earth is this returning void? What is wrong with me? No, we're going to return a base ECS component because that makes way more sense, and also we're going to return a null pointer if it's not found. So yeah, it's going to return base ECS component pointer, and this is just going to return a component pointer. In fact, while we're at it, I'm going to update remove component to return a boolean, because that makes more sense to me. So bool is going to return move component internal. If I can spell return correctly, where are you? There you are. We have returned the return name to its proper name. And bool. Here we're going to return true because we did remove. And here we're going to return false because we did not remove. And do we need to have anything special for add? I don't think we need anything special for add. That should be everything. So awesome. Now we have entity methods complete. We can do entities all we want. We have the component methods complete. We can do components all we want. All that's left are the systems. Surely they can't be that bad, right? Oh, viewers. Systems are where it all comes together. All the complexity of the component's dynamic runtime type system, all the weirdness of the entities not having their own class and having to be these opaque handles to this crazy pointer to pairs of indices to arrays, all of it will come together in the system. And it all has to work together seamlessly to be able to efficiently deliver the right components to every single system. How can we do it? Can we do it? All will be revealed next time when we take on the de facto final boss of creating an ECS system. I hope you enjoyed, I hope you learned, and I hope you're ready for the next video where we're going to be taking this final challenger down. As always, If you want to talk more with me or other like-minded people, consider joining the Benny Discord. It's an awesome place, and you are always welcome. If you want to support these videos, or possibly find out right now, consider becoming a patron on Patreon. You can get early access to videos, you can get special bonus video materials, special roles on Discord, you could even get a special thanks from me in these videos. Thank you very much to all my patrons for making these videos possible, and a very special thank you to those listed in the video description. Thank you very much, and I will see you all next time.